So now let's see what the other protocol called P-persistent CSMA is. First, it applies to slotted channels. So this is kind of taking its idea from slotted Aloha. It means here you are discretizing the time. You are not allowed to sense or transmit at any moment of time you want. The time now is not analog. Now the time is digitized. You are only allowed to transmit with certain slots, so that if there is what's the advantage of having slotted transmission? You avoid collision due to partial overlap between the data packets, and this is it reduces the probability of having collision and therefore improves the throughput of your system. So it applies to slotted channel. When a station becomes ready to send, it senses the channel. When a station has data to send, it senses the channel as usual, as always. If it's idle, it transmits with a probability P. Now, the probability of transmitting its data, if the channel is idle, is not always 1. It transmits it with a certain probability. It means that it can transmit, it cannot transmit. In one persistent CSMA, whenever the channel is idle, you always transmit with a probability of 1. But there is also a possibility for collision if you find the channel, even if you find the channel to be idle, because some other nodes might be preparing to transmit their own data at the same time. With this probability in P-persistent CSMA, when you have a probability, you are not always sending with full probability. You reduce the possibility of having collision. So with a probability equal to Q, which is equal 1 to minus P, it differs until the next slot. If that slot is also idle, it either transmits or differs again. It differs means it backs up. It delays its transmission. This process is repeated until either the frame has been transmitted successfully or another station has begun transmitting. So if another station has begun transmitting, what will happen? It stops transmitting. It understands that this probability mechanism was really useful to the node because it won't cost the node energy and resources and cause delay just because of sending one data that was exposed to collision. So in the later case, when the station has begun transmitting, the unlucky station acts as if there had been a collision. It waits a random time and starts again. It waits a random time and starts again. Yes, this might be seen here, this point might be seen as a disadvantage. They call it here unlucky station because it had to wait now. It had to wait at that time, but this is also can be seen as an advantage because it avoids collision. And what factors determine which thing is better for you is your application. Is your application delay sensitive or collision sensitive? Are you okay losing your packet and retransmitting again and you have plenty of power and plenty of resources? Or are you an Internet of Things device which is limited in its resources and battery and power and size and memory and processing and CPU and RAM and memory, and you want to make sure that whatever you transmit it goes through? Or you are a powerful server always plugged into power and you have enormous transmission capabilities? Who are you? Based on this, you can determine which protocol is better. So this is how you should understand things and relate them to practical devices. If the station initially senses the channel and finds it busy, it waits until the next slot and applies the above algorithm. So this is how P-persistent CSMA works. And here we have a diagram that summarizes all of them together in one slide. Behavior of 3 persistent methods. So we have first method is 1 persistent, second method non-persistent, and third is P persistent. So in the first method, as you can see in the visualization figure over here, the node, if it uses one persistent CSMA, it continuously keeps sensing the channel, even if it finds it to be busy from the first trial. Why the node is doing this? Because it wants to make sure that it can seize the opportunity of transmitting its packet whenever it finds the channel to be idle or free. And this unfortunately can lead to collision because some other nodes might be also at the same time preparing to transmit. In non-persistent, you save the energy you need to keep to continuous sensing, and rather you just sense after certain period of time at random intervals. So it first, for example, the node first senses the channel, it finds it busy, it waits for a period of time, senses it again after a certain period of time. It doesn't continuously keep sensing the channel because it's not interested too much in seizing the channel whenever it's idle, under the risk of having collision with other nodes, but also it saves its resources and makes sure that the probability of sending its data without collision increases compared to one persistent. And in p-persistent, here you kind of continuously sense and busy, but after that you are allowed to transmit your data with a certain probability, not with probability 1, and this probability is helpful in also reducing the collision. So these are the key differences between one persistent, non-persistent, and p-persistent protocols.